So let's think about a few simple matching networks, and I'm going to basically discuss very briefly the single element matching. So single element matching means adding an inductor or capacitor. Remember, it's lossless, so resistors are not allowed, at least not at this point. We'll discuss a little bit later on where resistors might become useful. But for right now, I'm adding L and C in series or parallel. So adding an L in parallel actually is something that is easy to see. We already discussed it a little bit, but essentially a series inductance can only add me a positive reactance. And so that means if I think about what kind of load might benefit from this matching network, only loads that already has a real part of 1 normalized and have a negative reactance can actually be matched by this load, by this matching network. So which means if I look at my Smith chart, only loads that are basically located right here can actually benefit from this matching network. So in other words, the locus of possible loads that can be matched from this network is basically that semicircle that has a real part of 1 and negative imaginary part. Now in real life, I remember that we discussed it last time. Remember that we're not just hitting ourselves to the center of the Smith chart. We are allowing a certain window because there are, again, circles of different matching performance that is acceptable. So if loads in this circle are acceptable, then it means that any matching network that will land me in that circle, which looks something like this, actually is acceptable. So the whole range of loads that lie in this region will basically benefit from a series inductor. So a series inductor is used often in real life. For example, highly resonant antennas, particularly small antennas that are highly capacitive, will severely benefit, seriously benefit from this, since it's pretty easy to cancel a series inductance with this. Now, equivalently, if I think of a series capacitance, now my capacitor has a negative reactance, which means only loads with a positive reactance might benefit, which means similarly my acceptable ZL will be somewhere here. So any loads close to that region that can be matched, you should think about the possibility of a series cap. Similarly, if I look at my shunt loads, if I look at my shunt L, that basically means now if I think in terms of Y, I need to have positive Jx since the imaginary part of the inductor will be negative Jx. Essentially, that means that I should be on that circle I showed you before, and I should be down here. And similarly, if I look at the shunt capacitance, I should be here. So this is the possible loads ZLs that can be matched with a shunt L. These are the possible loads that can be matched with a shunt C.